Let's chat. So we're doing, so you guys know we learned what sine, cosine, tangent, cosecant, secant, cotangent. We learned all those, right? But we only learned them with triangles, but they actually work on the unit circle as well. And so we're going to be finding those 6 values for any angle on our unit circle today, okay? So that's our goal, is to get you guys to know how to do that. So go ahead and begin with me here. We're going to start by drawing a cycle.
What did you just say?
A cycle. I'm related to Bugs Bunny.
I just watched the Bugs Bunny movie last
Now, I'm going to draw a radius right about there at some random place. That's probably good enough. Now, this angle here, we're going to call that theta. We're going to call that theta. And this is a radius of the unit circle. So what does how long is this line? 30 people in here don't know the answer to that? This is the radius of a unit circle. What's the radius? I have to give up on teaching.
Yes, give up.
Okay, the radius of a unit circle is 1.
I just said 1 like a bunch of. Now I'm tuning into that.
Oh no! All right.
You just tune out the smart kids.
Now, here's what I'm going to do. Is I'm going to turn this into a triangle. We've done this before by dropping a line straight down. And the horizontal distance here, I guess I'll color code it because I can. The horizontal distance, that tells me how far over this point is, right? Black for this. So this horizontal distance here tells me the x value, doesn't it? How far over that dot is up at the top? Doesn't it? Doesn't it? Yeah. Okay, good. All right. And this vertical distance here tells me what?
Why?
Because I want to know. So now that we have that, nope. Okay, so thing number 1 I want you guys to write is this. Let's find sine. Sine of theta. Now sine, as you guys know, is opposite over hypotenuse. So what's my opposite? Y. And what's my hypotenuse? 1. So it's y over 1, which we can just say what? It's just y. Because you don't need 1 in the bottom, right? So y over 1. And what's cosine? Good. And what's my adjacent? X. So x over 1 is what? Just x. Now, we just had an interesting breakthrough, and we're going to play on this a little bit more in another day. But for now, we just realized something. Cosine gives you x, sine gives you y. So we're doing unit circle stuff today, so this isn't going to be too useful for what we're doing today, but it will come in handy another day. You know how we found all the coordinates on our unit circle? And then you guys recorded them, and now you've memorized them and all that? Well, if I asked you to find the coordinates for a weird angle like 70, you wouldn't be able to do it because, it's not on your circle there, right? Well, with this, you can. All you have to do is do cosine of 70, you've got your x, and sine of 70, you've got your y. Okay? So this strategy will get you the coordinates for any point on the unit circle. But we're going to do that another day. Okay? Today, all we're doing is we're figuring out what are the trig ratios on the unit circle. So, next one, tangent. Opposite over adjacent, so what's that going to be? Y over x. Or, I'm not going to write this down, but that's going to come in handy later on in this year. We're going to learn that tangent is equal to sine over cosine, because y is sine and cosine is x, right? So it's all tangent is equivalent to sine over cosine. All right, now we're going to start getting into our reciprocals. Okay? Now, cosecant of theta. It is the reciprocal of sine, right? 1 over y. Now, just so you guys know, I'm putting this up here because this might come in handy later. But today, here's how we're going to do the problem. I wouldn't think of it as 1 over y. I would think of it as whatever y is, flip it, and you'll see what I mean when we get there. Okay? So, but for now, let's go ahead and continue. Secant is going to be what? The reciprocal of which one? Cosine. So this one is equal to what then? 1 over x. And cotangent is what? The reciprocal of tangent, which is x over y. Okay? So, we can find the sine, cosine, tangent, cosecant, secant, or cotangent for any angle on the unit circle by just, if we know what the coordinates are, x and y, which you do because they're on your circle, we can calculate all the other ones, and that's what we're going to do today. Okay? So that's our goal. All right, guys, here we go. We're going to be using our unit circle to do a lot of the work today, okay? So the first thing that you're going to do is you always want to start off by finding your point on your unit circle. Let's do that first. So can you guys find where 300 is at on your unit circle? Okay. Now, we're going to start by finding sine and cosine first because they're the easiest. All right, so what we learned was that sine is what? Sine is basically just the y value. So look at your unit circles. What is the y value at this point?
It's the radical, negative radical 3 over 2.
I will agree with that. She is correct. It's negative radical 3 over 2. All right? Now, what is cosine basically? It's x, which is, in this case, 1/2. Good. So, there you go.
Is it negative? No.
And if you guys wanted to, I don't want to take the time to do this right now, but if you wanted to, you can get your calculator out, and you could do cosine of 300, you're going to get 1/2. Or you could do sine of 300. You're going to get negative 0.866, which is what this equals if you turn it into a decimal. Okay? So, those two are the easiest. Let's go ahead and talk about tangent now. Tangent requires a little bit of work. Sometimes. Now, tangent, according to our notes that we took today, is what over what? Y over x? So, it's y over x. Now, when we saw these earlier this year, I showed you how to do this. But I'm going to show you just a nice thing that tends to almost work every time on here. So, you don't have to do the hard way. But what we learned at the beginning of the year was that if I don't like that little bottom number, we multiply the top and the bottom by that, right? All right, but here's the thing. With the unit circle, the bottom's always 2. And how it's going to work is you can just cross it off. Boom, boom, and there's your answer. Nice, right? So we don't have to sweat about that too much. All right, now we're going to get into some other stuff here. Let's talk about cosecant. Now here's the thing. I was almost debating on whether or not I wanted to tell you this earlier today. When we wrote this earlier, I was almost debating on whether I want to tell you that. And I decided to keep it because it might come in handy for some stuff later. But for today, that's only going to confuse you. If you guys do this, cosecant is 1 over y. If you write this, I mean, I'm okay with it so long as you're okay with having to do a lot of simplifying. It'll work. But I'm going to give you guys something that's much, much easier. Okay, and this is what I would encourage you guys to write on your notes. What's much, much easier is just find the reciprocal of this one up here. So just flip this thing over. Yep. It's still there. The negative doesn't go away. So that's so much easier. Just do that. Don't use the 1 over y thing, okay, for today. That might come in handy later, but for now, just take your answer from the top and flip it. You're good. Okay? Now, you can't. So we need to fix that. That's something that I can't fix for you. We actually have to do that. So no square roots are allowed on the bottom, so we multiply the top and the bottom by 3, radical 3, I mean. And we end up with a final answer of negative 2 radical 3 over 3. There's cosecant. Let's do secant of 300. What is secant? Good. So we're just going to take our answer from cosine and we're going to flip it. So instead of 1 over 2, it's going to be 2. But you could say 2 over 1 if you want to. I'm just going to say 2. All right. Last one, cotangent. Say that again. No, I don't think so. Say that again. Yeah, that's where I'm going to go with it. So cotangent is x over y, correct? I had to squish it in there. And so we're going to handle this the same way we did before, just drop out the 2's, right? But do we like square roots on the bottom? So we need to fix that. Good. So we're going to, that's supposed to be negative. We're going to multiply the top and the bottom by the square root of 3. And there you go. Okay, so you do have to rationalize. So here's what we learned. Sine is the y value. Cosine is the x value of that angle. Tangent is y over x. Just cross off the 2's. Cotangent is x over y. Just cross off the 2's. And when you have a square root in the bottom, you have to rationalize. Cosecant and secant, I would not start with 1 over y or 1 over x. Even though that could come in handy later, we're just going to take the x's and y's we have up here and we're going to flip them. Okay? So, there's that. Let's do a guided practice. This one will turn out kind of interesting as well. A little different. Go ahead and write down this one real quick. Yeah. All right, here we go. So, we start off with finding the points for that coordinate. What is it? 0, 1. So what is sine of 90? It's 1. What is cosine of 90? 0. What is tangent of 90? Huh? Yeah, good. So tangent is y over x, right? So if we put this, the answer is undefined. You can't have 0 on the bottom. Okay? There is no solution for that. Let's do cosecant again. Cosecant is the reciprocal of 1. So if I take this answer, think of it as a fraction, 1 over 1. If I flip it over, what do I get? It's 1 again. How about secant? Well, right now, you can think, if we think of 0 as a fraction, what would it be? 0 over 1. But if you flip it, what's it become? 1 over 0, which is undefined. So 0 has no reciprocal, so that's undefined. So I'll say that again. 0, if you think of it as a fraction, is 0 over 1, right? And if you flip it, it's undefined. You can't have 0 on the bottom. All right, last one is cotangent of 90. Cotangent is x over y, which is 0 over 1. And that just simplifies to 0. Okay? Anytime you guys are at these points here on the axes, one of those ones at the x or y axes, your answer is going to look like that. If you're at the other places, you'll have answers that we looked like last time. Okay? So, clear? All right. Your turn. Try that one there. It says example 1 still, but this is student practice now. What did you get for your sine value? Okay. Let's ask Jordan Martinez, what did you get for your cosine value? Good. Let's talk to Robert Bowen. What did you get for your tangent value? Okay. Let's try Austin Longmire. What did you get for 60? Tangent. I agree. How about Ricardo? What did you get for cosecant of 60? Say that again. Okay, you're right, but you have to rationalize it. So, all right, Dylan Smith, I'm coming at you. I know you're having a little bit of trouble with this one, but did you get to this point? Okay. Let's try our good friend. Kalen was busy. Yeah, but he was busy. Demir, what did you get for secant? Huh? 2. And then finally we have cotangent of 60. And we're going to ask Tristan. What did you get for that, Tristan? All right, so that's how you can find the 6 trig ratios for any angle on our unit circle. Okay, on our unit circle that we actually know already, right? Now, we'll worry about angles that aren't explicitly written on our unit circle later. For now, I'm gonna tell you guys your thing that we're doing. So just so you know, tomorrow is the second part of your state testing. So if you're a junior or sophomore, you're gonna be on the computer doing that test again. If you're a senior, you're chilling. My advice to you is that tonight you do this homework that I'm assigning you. And tomorrow, we're going to have a take-home quiz. But you'll also want to be studying your new part of our last part of our unit circle, the bottom half, called the tangent values. And I'm about ready to share those with you now. So, I saw a question over here, though, before we begin. Your unit circle ready? Now, a lot of teachers don't actually have their students memorize this part. Almost every trig teacher has their students do this. I do this, though, because I find that when it comes to solving equations, this makes life much easier to have it. And it's not that much more to remember, honestly. So, here we go. We actually already did a couple of them. So, what we saw earlier today was at 90, tangent is undefined. Tangent is undefined. Now, we didn't do 0 today, but I could figure that out really quick. I know that the numbers are 1 and 0, and so y over x would be 0 over 1, which is just 0. We also figured out 60 just a second ago. We got square root of 3. Okay. Now, just so you guys know, when it comes to tangent, we're going to use symmetry. So, just like the other one. So, if this is u, so is this. And if this is 0, so is this. Okay? And you can always find these out by doing y over x if you want to do it the hard way. But it's nicer just to have it memorized. Now, here's how tangent works. The lines that are closest to the y-axis will always be this value. Their signs may change, but they're all radical 3. So I'm going to put a radical 3 here, and down here also, and down here also. All of those will be radical 3s. The ones on the top left and the bottom right, though, are negative. Yeah. It goes right here on your guys' unit circle.
At the bottom where all the lines faded into.
If you want to put it on your notes for now, it's fine, but eventually I would get it on your sheet. So there's that. Now, I want you to notice something funny. Look at the signs. That corner is positive, and the bottom left corner is positive. But that actually makes sense. Remember, tangent is y over x, right? If I'm in this quadrant up here in the top left, what is y, positive or negative? And what is x? And what's a positive divided by a negative? So you get negative there. Whereas down here, what's the y value? Positive. I'm sorry, negative. The y value is negative. What's the x value? Two negatives make a positive. So it actually makes sense when you think about tangent as a fraction of the y and x's. All right, so there's that. Now, the next one here, the 45-degree angle. What do you guys notice about the x and the y at the 45-degree angle? They're the same. They're both square root of 2 over 2. And what do you get if you divide something by itself? 1. So this is 1. And the same sine rule applies. So this is negative and this is negative. Mm-hmm. Those are the radical 3s. Yeah. The ones that are closest to the y-axis are the radical 3s. Now, the last one, the ones that are closest to the x-axis, there's 4 of them. The ones that are closest to the x-axis, they're also a radical 3, but radical 3 over 3. It's a fraction. So it's radical 3 over 3, radical 3 over 3, radical 3 over 3, radical 3 over 3. And the same sine rule applies. So this one's the negative and this one's a negative. And those are your tangent values. Those are nice to know for future problems that we'll be having.
You are so correct.
So I'll pause there. So once again, I'll say, now, guys, I have some other it's interesting you're packing up. We're nowhere near the end of time here. But, yeah, we got more. We have a couple other examples I want to share with you guys before we call it a day. So, hold on. All right. Ready? So here's the deal. You're going to be given angles that are either too big or too small. They're not going to be angles that are actually on our unit circle. But, despair not, we know how to fix that. Here's the deal. I don't know what 840 is all about, but I do know it's coterminal with something, right? I want angles that are between 0 and 360. So how can I find an angle that's coterminal with 840? Subtract 360. So if I subtract 360, I'm going to find an angle that lands at the same spot, and therefore would have the same x and y values and all the same trig ratios. But you have to get it to be between 0 and 360, which is on our unit circle. So I don't think this gets us there yet, so we got to do it again. Subtract another 360. So 120 is on my unit circle. So now that we have that, we can answer the question. What is sine of 120? I don't think so.
Wait, what?
I want to know sine, which is the y value. Okay, there we go. Radical 3 over 2 is the answer. I'm not going to do all 6 this time. We've got enough of that. We're just going to do 1. But there it is. No. Yeah, I don't think you would have. So, a little note you might want to add then is, we need angles to be between 0 and 360. All right. We good?
No. Sure.
All right, one more problem of an example here. No, we're just going to call it like the second part of number 2. So write down this one. Aha. Aha. Why does it say that? And we're gonna do secant for this one. We're gonna do secant for this one. Okay, now I'm gonna ask you a question. Some of you guys are gonna be tempted to answer wrong, so think carefully. Quiet, please. All right. So I'm gonna ask you a question. You may be tempted to answer wrong, so think carefully. Is this angle between 0 and 360? No, it's negative, right? We want between 0 and 360. So I need this angle to be bigger or smaller. So if I want it to be bigger, what do I need to do?
360.
Okay, so I'm just going to put 360 on top of it. So because when you combine a negative with a positive, you got to subtract them anyway. So it's 210. Okay, so this is a 210 degree angle. So on our unit circle, since I've taken the time to memorize my unit circle, I know that this is negative radical 3 over 2 and 1/2. Negative half. Right? Now the problem's asking me to find secant. Now what is secant? It's the reciprocal of cosine. So this is cosine, right? So it's the reciprocal of that. And we need to rationalize it. But we've done that already today. What did that turn out to be? So after you've done it so many times, you can start to realize you just keep getting the same answers over and over, just in different places. So there you go. All right. You guys can be done now. You can pack up if you want.